Alright, in this video we're going to be working AP Pre-Cal Homework 7.1. We're going to be graphing a lot of sine and cosine functions and answering some questions about, aspects of the graph like amplitude, period, midline, phase shift. Okay, and like you can see on the screen. So we're just going to start with y equals sine x. And I think that's going to be good for us, just get started with just the standard graphs. Okay, so what we need to know is kind of the standard sine x graph, and I'm not gonna go into it here. I'd just direct you back to the lesson video if you were confused on why these were the points on the sine graph. I need this pen to be thicker. Okay, so it really has to do with the fact that on the standard 0 to 2 pi interval, sine starts off at 0, increases to 1, decreases back to 0, and then to -1, and then increases back to 1. And, in the lesson we looked at how the graph was curved. That gave us a nice graph of y equals sine x. Okay, and then, what we did, we said the standard period's 2 pi, the standard amplitude's 1, there's no shift or anything going on here. So, because there was no phase shift or vertical shift, these are zeros here. The period's 2 pi over here. In x coordinate. In y, I'm down at -1, and I'm up at 1 up here. Okay. So I think, I haven't labeled quite everything. I can label this. And then I like to also label the axes as well. So wherever x is 0, that's going to be the y-axis. Okay, that'll work. Wherever y equals 0, that's the x-axis. All right, great. And we've got ourselves a nice looking graph here. All right, now we're going to do cosine x, and cosine's the one that starts at the top. Like this, starts at the top and then follows the same pattern. Okay, so it's going to go down. Come back up. And just like sine, cosine has period 2 pi, amplitude 1, and there's no transforms or anything going on here. Alright, so this is going to be the y-axis again. And that'll be the x-axis again. And, okay, I guess I can go in and label these spots. Alright, there we go. Now, I think it's also going to be important for me to mention, maybe I'll go off on a different page. Yeah, these are going to be some rough sketches, but I think I should also talk about negative sine and negative cosine. So, y equals sine x, that's the one that starts in the middle and is going up, starts coming up. And so, negative sine is just going to do the opposite. It's going to go down. Like that, and of course this is not a very good sketch because the rectangles are not squares or evenly spaced or anything. But negative cosine, okay, regular cosine starts at the top, negative cosine is going to start at the bottom. It's like that, and we'll probably need to use those when we encounter one that's got negative number out front. All right, so for number 3, y equals 2 sine of 2x plus 3. I'm going to start with just kind of the parent graph, which is sine. So we plot those points, we connect the dots. That same wave pattern we saw earlier. And then, okay, now we're going to kind of get to work on the other stuff. So I think the first thing, phase shift is the number, or pardon me, the vertical shift is the number that's outside. That's going to affect the midline. So vertical shift is 3, so the midline is y equals 3. I'll put that there. And then the amplitude is going to be the vertical stretch factor, vertical dilation. So I'm seeing 2 there. label that amplitude's 2. So that means I'm going to go up 2 units from 3 and down 2 units to have the maximum and minimum values of the function. Okay, the period, I'm going to be able to compute that using the formula period equals 2 pi divided by b, where b is that multiplier right there, that 2. I just put an arrow towards it in blue, so it's going to be 2 pi divided by 2, which is equal to pi. Okay, I don't know why I said 0. I think I was thinking about the phase shift. Period's going to be pi. Okay, and so now thinking about the phase shift, I'm not seeing any kind of like x minus a number or x plus a number on the inside of the trig function, so I'm going to say the phase shift is 0. So that means that I'm starting off here at x equals 0. And then I'm, okay, to the end of the first cycle, that's going to be pi. Okay, so I'll divide it in 4 and say pi over 4, 2 pi over 4, 3 pi over 4, and pi. And then last of all, I like to draw in the axes. So that would be right here. And okay, so the other one, if it's below 1, it's probably about right here. So that's going to be a nice graph for us. Next one is a negative cosine. So that's what I was saying before. If we see it's a negative cosine, we can just know that we're going to start at the bottom and graph like that. Okay, and thinking about, I guess I can do it. See, no, I actually don't think that's the way to go. I really think it's good to label the vertical axis first because that's the easiest, and then move on to the horizontal axis, and then draw the x and y axes last of all. So I'm going to start with a midline, and that's that -2 right here. That's that number on the outside. So it's a vertical shift of -2. And then I'm going to think about the amplitude, which was negative, well, I guess it was 4. It's the number that's multiplied against the cosine. In this case, the negative cosine. So I'm going up by 4, so that's up to +2, and down by 4, so that would be down to -6. Okay, the phase shift, again, I'm not seeing any number, subtracted or added to the x. So phase shift's going to be 0, so I'm going to start there. I don't think I didn't write in that the amplitude was 4 here, but for the period, it's period equal to 2 pi divided by b, where b is that multiplier number right there. And so that's pi, 2 pi over pi is 2. So I'm going to go over here to 2, and halfway between 0 and 2 is 1, so it'll be 1.5 and 0.5. And then I might also draw in some axes. Maybe we'll get one with a phase shift here in a second. And then the x-axis, that'll be between -2 and 2, and it'll be exactly halfway, so I'll do the best I can to cut that in half. And then draw an x-axis there. Alright, now this one is a positive cosine, so I'll start up at the top. Drawing the graph. This one is not feeling like it's going to be all that great. But like I was telling you in class, as long as it's increase, decrease behavior and its concavity is right, it doesn't have to look perfect. And so if it's got both of those, it's not worth erasing and trying to make it look perfect. Just live with what we got. So the phase shift of this one is 3. So I'll start there this time. If I have the phase shift and I want to know what's going to go over here, I need to know the period. So I'm going to say period equals 2 pi divided by b, which was pi over 4. So dividing by pi over 4 will be like multiplying by 4 over pi. And I'll have period 8. So from 3 to 11 here. And then, okay, if the period's 8, we got 4 squares, I think we should just add 2, because we divide 8 by the 4 and we get 2, and so the change, take over from one square to the next will be 2, 3, 5, 7, 9, 11. Yeah, just do it however you're going to do it. right? But if you wanted to average 3 and 11, add them together and divide by 2, you would get 7, and then you could do the same thing to get 5 and 9. Or you could just, do it however you see fit. The amplitude, well, I don't think the amplitude will be as much use to us if we don't know the vertical shift first. So the vertical shift is 2, and so I'll put that number there. Oh no. Why does it do that? Amplitude is going to be 2, and so it's going to go up to 4 and down to 0. And then I fill that in, draw some axes. Okay, so the y-axis will be done. I mean, the x-axis, that'll be down here. Okay, I don't think that's good enough. That's not on the line, so, I don't know, that's kind of vanity. Maybe I'm just committed to it now. After I was just saying don't obsess over making the graphs perfect. We've got that there. We're going to draw in a y-axis, and that'll be off here to the left, and it doesn't matter, the relative distances here, that's not important. What I think is good is if you draw the axes, then you can kind of see that, okay, I'm over here in the first quadrant, kind of a ways to the right, to the y-axis. 6, -3, this one's got all sorts of moving parts, doesn't it? So I'm going to start with the vertical shift. The midline is going to be 2 again. And then the amplitude is going to be 3. So I'm going to go up to 5 and down to -1. And then the phase shift is going to be pi over 4. It's the amount of horizontal translation. So put that down here, pi over 4. And then the period, I'll have to do the computation. The multiplier was 4, so p equals 2 pi over b, which was 4 there. And I will say that's pi over 2. So I'm going to add pi over 2 to pi over 4, and I'll get 3 pi over 4. Okay, I think halfway between pi over 4 and 3 pi over 4 is 3 pi over 2, and I just know that thanks to the unit circle. And then halfway between these two, wait, no, that's 1 pi over 2, pardon me. Yeah. And so you could think of it as 1 pi over 4, 2 pi over 4, 3 pi over 4, and so then you would know I would need to go into eighths of pi. So 2, 3/8 of pi, pi over 2 is 4/8, then 5/8 of pi, 3 pi over 4 is 6/8. This looks like the scales, it's right. All right, then I'm going to draw, oh, I didn't ever draw the graph, it was negative sign. So it's down here, but I guess that doesn't really matter. You could draw the graph last of all if you wanted. Especially if you knew like all the parts that you were looking for. Right. Down here, like, yeah, that's definitely favoring the -1 over the 2, probably more than it should, but that's all right. And, who knows about the relative scale here, but who cares? Over here in the first quadrant again. All right, the next one is talking about identifying the key characteristics just from looking at the graph. Okay, and that'll be great. So, not that many points are labeled like we would want. Okay, so we're not going to be able to, oh yeah, I guess we will. Okay, I was thinking for period, I was, I default wanting to go top to top, but that second top spot wasn't exactly labeled. So I'm going to go from this middle where the graph is coming up over to the next place where I'm in the middle and the graph is coming up. So that's one full cycle. I went from 0 to 4 pi. The period is 4 pi. Okay, the amplitude is going to be, clear that work out. Amplitude will be the distance from the midline, which I might actually draw in. And so I'll say the amplitude is the distance from the midline to the maximum or to the minimum. So I'm going from 3 to 7, that's an amplitude of 4. And then you could also see I'm going from 3 down to -1. Phase shift for sine x. All right, so for sine x, the thing that we're looking for, if we're kind of going backwards, we're thinking about how the window pane technique, how it starts. And it looks like that. right? At least near the origin, because it starts in the middle and goes up. So we're looking for a similar place where it starts in the middle and goes up. And I think the simplest would just be to say right here, and that's x equals 0, so the phase shift will be 0. And then the phase shift for cosine x, okay, think about where cosine starts, that's up at the top, right? Looks like that. So we're looking for a place where it's at the top, that's right here, that would be pi. And the vertical shift, that's the y-coordinate of the midline, and that's going to be 3. All right, so for f of x is a sine graph, so we're going to use the phase shift for sine x, which is 0. And so that's good. I'd kind of wondered how we were going to do that. So it's 4 is the amplitude times the sine of b. Okay, now the period equals 2 pi over b, and so 4 pi equals 2 pi divided by b, so that means b needs to equal a half. If you want, you can cross multiply or just multiply both sides by b, and then divide it out. See, it's going to equal 2 over 4, which is a half. Okay, so it'll be b times x plus the phase shift for sine was 0, and then plus the 3 there. All right, and then for g, I'm going to have 4 cosine, and I'm just going to use what I've got. 4 cosine of the same multiplier, 1/2, but there was a phase shift for cosine, that was pi, so we'll do x minus pi there, and then again, plus 3. All right, for this one, for the period, I'm just going to look top to top, and that's going to be 0.5 to 2.5, that's a width of 2. Right, the amplitude is going to be, I'll just draw in the midline here. Usually would make that dotted, but I think that's all right. You can still see where the x and y axes are. And the point, there's so many points labeled that I think we're going to be all right. The vertical shift is 2. So I'll write that in. The amplitude is the distance from the midline to the maximum, or the midline to the minimum. And so that's from 2 to 5 is an amplitude of 3. Phase shift for sine, I'm looking for a place where I'm coming up, in the middle, and that would be right there, so no phase shift for sine. For cosine, I'm looking for a place where I'm at the maximum, because that one starts out like that. It's a really bad graph, and so that would be 0.5. And so f of x is a, which is the amplitude, 3 times the sine of b equals 2 pi. Oh wait, yeah, well it is going to be true that b is 2 pi over the period, but I really like to say period equals 2 pi over b. I think that it's one formula we want to remember, not two, even though they are kind of interchangeable. Period equals 2 pi over b, b is going to need equal pi. And then there was no phase shift for sine, and a vertical shift of 2. A for g, that'll be a 3 cosine, same multiplier, but there was a phase shift of 0.5. X minus 0.5. And then adding 2 the same way. Okay. Now, sinusoidal function created the table of values below. Minimum values of create x values that are multiples of 4. Okay, cool. And write an equation for f of x that can define the function using transforms of sine and cosine. All right, so I think I'm just gonna on ones like this, I'm just going to suggest we make a little window pane. I think that should be enough, and then we can kind of just go backwards from there. I see I'm going from 7 to 9 to 11 to 9 to... Oh, so I started off at the bottom. I didn't realize that. I thought I was going uphill. Hold on, let me space that out a little more evenly. That'll be better. Alright, so since this one's starting at the minimum, I'm going to want to use negative cosine. Okay, now that's going to be... So really that would be the standard window if I was doing the window pane technique. And it starts off at x equals 0, so I'm going to have negative, maybe some number of cosine of maybe some number of x's, but I'm not going to have a phase shift. And then maybe plus some other midline number. So I'm seeing in the middle I've got 9, and then 7 on the bottom, and 11 up here. Okay, so the amplitude is 2, the midline is 9. Need to figure out what the period is. Okay, from the first 7 to the second 7, that's where it repeats itself, I went from 0 to 4, so the period is 4. Period equals 2 pi over b. So 4b equals 2 pi, and b will equal 2 pi over 4. Okay, so I'll say that's pi over 2x. And so that'll be one formula for f. And then if I wanted to do a formula for f in terms of sine, what I'm going to do is I'm going to look for a different place to start my window. So I'm just going to instead do the window here, okay, because I know it's going to be a positive sign because it's where it's coming up through the middle. Then I just got to figure out where that was. Okay, that was at x equals 1. And then it looks like 2, 3, 4, 5. Maybe I'll just check to see, did I go from 9 to 9, from 1 to 5? Yes, great. Wonderful. So, yeah, then I'm going to go over here and I'm going to say, alternatively, f of x, I could write this is going to be positive 2 times the sine of pi over 2. I did have a phase shift. I started my window at x equals 1. So do x minus 1 plus the same 9. Alright, and it looks like this one's exactly the same, so maybe I'll draw a slightly nicer box this time, knowing how it's going to go. That'll work. And I'll cut it in half here, cut it in half again. Just keep cutting it in half. Okay, great. So at negative pi over 2, that's where it's starting. So I'm seeing 2, 5, and 8. So I'm going to be a little smarter this time and think about where I'm going to start my window to kind of make it easiest on myself. Okay. And so it starts 2 to 5 to 8. It's another one that starts at the bottom. But maybe you didn't want to have to do negative cosine. Maybe you want it to be regular sine. We started with regular sine. Is that what no, I started with cosine last time. Yeah, so maybe we can start with regular sine here. And so what regular sine, the phase shift is going to a place where we're in the middle and coming up. So that's going to be one right here where I'm at 5 and I'm increasing from 2 to 5 to 8. So that's going to be pi over 2. And I'll plot my point there, 5 to 8 to 5 to 2, back to 5. All right, so I already know that the midline's 5, the amplitude's 3. The period went from pi over 2 to the next place where f was equal to 5 and coming up was 9 pi over 2. Okay, that's fine. See, it looks like I increased by 8 pi over 2, which is 2 pi. All right, so the period's 2 pi, so I would add 1 pi there. That can't be right. 8 pi over 2 is 4 pi, so I would need to add 2 pi. And this, okay, this looks more right, in terms of even spacing. Yeah, that's more like it. But I guess I didn't really need those labels there. And, oh man, that was foolish because it was in the table the whole time. I didn't even think about that. All right, so I've got the graph. I'm going to say for sine y equals amplitude is 3 times the sine of period is 2 pi, so b equals 1. Sine of x minus pi over 2 plus 5, the midline. And if I wanted to do 1 in cosine, then I was going to start my window over here, add an extra 1, but I won't need that. All I need is just the idea of the phase shift being right here. And I could say also y equals 3 cosine of x minus 3 pi over 2 plus the 5. Right, so what is the best description for the graph of f of theta equals negative cosine theta on the interval pi to 3 pi over 2? So I think I'm going to just really emphasize the window pane method. Maybe I'm not going to draw out a whole box, but negative cosine starts at the bottom, goes up to the top, and comes back down, and that'll be 2 pi. Let's see, that's 2 pi. Okay, so that means this is 1 pi, and that'll be 1.5 pi, or 3 pi over 2. So if we were to draw in the graph, we could do the whole thing, but really all we need is this piece. I think that'll make it clearest. It's decreasing and concave down because the graph is frowning. All right, regular cosine of theta, I'm going to do the same thing. Start it up at the top. And that's 1 full cycle, that's 2 pi. So if I want 3 pi over 2 to 2 pi, 3 pi over 2, and here's 2 pi. I should have drawn this much more spaced out, but it's all right. That's going to be increasing because it's going uphill, but still concave down because if I drew eyes on it above the curve, it would be frowning. Or you could say it's increasing at a decreasing rate. Then what is the best description for the graph of f of theta equals negative sine theta on the interval 0 to pi over 2? All right, so this one. Okay, 0, pi over 2, pi, 3 pi over 2. That was a cosine. Okay, well, at least I caught it. Sine starts in the middle and it's coming up. And so there we go, we graph our points. 0 to pi over 2, it's going to be increasing and concave down. Increasing at a decreasing rate. Oh, that was regular sine. Man, I messed that up twice. That's rough. Thankfully, I got suspicious when I got the same answer the second time. Okay, so over here, draw the same graph, just upside down, and it's decreasing and concave up. It's kind of smiling. So decreasing and concave up there. Alright, now this one, I really like this type of problem here. This graph shows one cycle of a periodic function g in the xy plane. Describe the behavior of g on the interval 39 to 42. It's like, oh man, they only gave us room for 0 to 6, and if I just try to keep the pattern going, I could maybe get to 12, but like, I'm going to have to really think about this. So what we do is we say, okay, the period is 6, and that means that every 6, the thing repeats itself. So at 12, it's going to look just like it did at 0 and it did at 6. And at 60, it's also going to look exactly the same as it did at 0 and 6. So what we need to do is find the nearest x value that'll be like the end or beginning of a new period that's less than 39. And so if the period's 6, which I'm seeing from that, I'm going to say, all right, the nearest one is 36. So what I'll do is I'll just say, all right, this is now 36, and the period was 6, so this is now 42, and just ignore that y-axis, and this is now my graph. Okay, I really think this is the way to solve this type of problem. So we're asking about 39, okay, well 37, 38, 39 here. From 39 to 42, the graph is increasing and then decreasing. So that would be this one. Okay, now it looks to me like if we're gonna check the period of this one, it's gonna be 5. Okay, and 25 to 27. Okay, well, if the period's 5, I'm looking for the nearest multiple of 5 that's less than 25. Well, that would, I mean, I guess less than or equal to. And I'll say that's equal to 25. And maybe this is now 25, and the width of the period was 5, so this will be my 30 on my graph. And now this is a new graph, and I'm ignoring the y-axis. So 26 and 27 there. Okay, so on the interval 25 to 27, this thing is only decreasing because, I mean, best I can tell, that's a maximum in x equals 0. I gotta think it is. Maximum at 0 and 5. So from 25 to 27, be here to there, the thing is only decreasing. All right, now here we've got a couple of transformation questions. All right, great. I haven't seen these in a while. Right, so they are saying we're giving the translations and then also the period. Okay, so I'm not seeing any sort of like amplitude discussion, so I don't think there's gonna be any like multiplier up front. So g of x is gonna equal, right? I guess you're just saying sine of some number of x minus pi, or x plus pi, because I went pi units to the left, and then 5 units down, so minus 5, and the function has a period of 5 pi, so there was some sort of horizontal dilation, and so the period equals 2 pi divided by b, and then I would say outright b times 5 pi equals 2 pi, and then b is going to equal 2 over 5. Alright, so 2/5 of x plus pi minus 5. Okay, yeah, that works. Yeah. Alright, translation 10 units to the right and 2 units up. It doesn't matter what order we do those in, though. So g is going to equal, okay, no discussion of amplitude, so it's just going to be regular cosine of, okay, 10 units to the right, replace x with x minus 10. Okay, the period is 12, so 12 equals 2 pi over b. B will need to equal a sixth. I guess pi over 6, pardon me. I mean, that's why I should have, period of 12, yeah. So b is going to be 2 pi over 12 is pi over 6. Okay, so pi over 6 times x minus 10, and then it said also 2 units up, so plus 2 on the outside. All right, f of x. All right, so we've got a phase shift of pi over 6, and what are the locations of the first maximum and the first minimum of f of x when x is greater than pi over 6? All right, so going over here, and I want to just draw a window. I really think that's the way to go. Okay, I guess we're gonna go with a slightly slanted window here. That's all right. We can work with that. This one's really, really bad. But, you know, it's going to get the job done. Yeah, okay, that's really one of the worst yet. But, okay, regular sine is going to start in the middle and have that pattern. But we're seeing a maximum and a minimum, so this is going to help us answer the question. All right, undergoes a phase shift of pi over 6. Now we need to find the period. So period equals 2 pi divided by 3 halves. Okay, so that's 2 pi over 1 divided by 3 halves is like multiplying by 2/3. Really? Let me just look at that one more time. Divided by 3 halves, multiplying by 2/3. Okay, period is 4 pi over 3, which is 8 pi over 6. And, okay, I'm going to say 8 pi over 6 plus 1 pi over 6 is 9 pi over 6. That's going to be 3 pi over 2. Right, now if the period is 8 pi over 6, each square will be 2 pi over 6. So it'll be 3 pi over 6. And then 2 more is 5 pi over 6. 2 more is 7 pi over 6. And then 2 more after that is 3 pi over 2. So for x greater than pi over 6, I'm saying a maximum right here at x equals pi over 2. And then for the minimum, I see that happening over here at 7 pi over 6. Right, now the next one. Better window here. Okay. Now, this is sine of 2/3 x, so it's going to be another regular sine. Right, and O undergoes a phase shift of negative pi over 2. I don't know why I would think that negative pi over 2 is an answer. Am I missing something here? I don't know, okay, I'm just going to keep proceeding. Alright, I'm going to just keep going. I'm seeing the maximum and the minimum there, so that's what I'm kind of angling for eventually. The period is going to equal 2 pi over b, which is 2/3, so that will be like multiplying by 3/2. 2 pi times 3 divided by 2, so that's going to equal 3 pi. Okay, so 3 pi would be 6 pi over 2 minus pi over 2 is a 5 pi over 2. And then I think I'm just going to add these two together and see the period is 3 pi, so it'll be 1.5 pi. Oh, okay, so yeah, that'll be just 1 pi there. And then, okay, so 5 pi over 2 plus 2 more is 7 pi over 2. Divide that in half, average them, I get 7 pi over 4. Okay, negative pi over 2 plus 2 pi over 2 is positive pi over 2. Divide that in half, that'll be pi over 4. I'm just averaging. All right, so the maximum is going to happen at x equals pi over 4. Okay, for x greater than 0. It's a sine graph. Okay, whatever. The minimum is going to be at x equals 7 pi over 4. Maybe we meant to say it was a cosine. That would make more sense to me, but it'll be all right. I'm just going to keep going and work it as it was written. Is that? Yep, that's going to be all. This is going to be the last one. Great. All right, that's kind of been a long one. So undergoes a phase shift of pi over 3. Just draw. Do a little bit better than that. That'll work. Sine of 3x. This is still just a regular sine, so I'm going to still draw the same window as usual. And, okay, undergoes a phase shift of pi divided by 3. The period is equal to 2 pi divided by b, which is 3. So I add 2 pi over 3 to pi over 3, and I get 3 pi over 3 is 1 pi. Now, yeah, I think I do happen to know. You know what, I'm going to think about this all in terms of pi's over 12. So this is 4 pi over 12, and this is 12 pi over 12. I need 4, squares worth of movement. So I went up 8, so that'll be 6 pi over 12, 8 pi over 12, 10 pi over 12, and pi. I think Yeah, I can see it thinking about the unit circle now, like how this would work, but I don't think I would have been able to see it like before. All right, and so the maximum is happening right there, and minimum happening down there. That's happening where maximum x equals pi over 2. Oh, this is where x is greater than pi. Great. Okay, I was hoping this would happen. Okay, so if x is greater than pi, and the period is 2 pi over 3, okay, I don't think that's going to be, just the easiest. I didn't notice that. I guess if I had noticed that beforehand, I could have phase shifted it by another 2 pi over 3 or whatever, but, too late now. So I'm going to just make a new window. Okay, I've got enough room here. And it doesn't have to be nice, so great. So there's the first minimum greater or maximum greater than pi. Here's the first minimum. Okay, so those yellow highlighter spots, those are just there to trick you, I guess. And there we go. So greater than pi, I need to say, all right, well, each of these was a 2 pi over 12. And so I'm just going to keep that going. Each of these window spaces should again be 2 pi over 12. So that'll be 14 pi over 12. So that'll be maximum at 7 pi over 6. 16 pi over 12. That's not the location of my minimum. I'm going to do 18 pi over 12. And let's see, 6, 12, 18. So that's 3 over 2. And the minimum happens at 3 pi over 2. Okay, that was a big graph, okay, but that was probably the only situation in which hopefully, at least for this lesson, you'll need to graph a second period of sine or cosine. And that was, after going through the whole lesson and the whole homework, the last one we had to do graph a second period. It wasn't so bad, was it? All right, so that's going to be all for this video. Thanks for watching.